So let's look at a graph we're told it's a transformed logarithm, and we're given the graph and we're given two particular points on the graph, and we're supposed to find an equation. And I'll be honest, I was a little confused at first when I was trying to do this one because I forgot how crazy logarithms are. They're so crazy, they're easy. So we can actually use any base we want for this logarithm. So just kind of go with it for a minute, but we're going to use or think of this as having the parent function. So the parent function y equals natural log of x. Now, why did I pick ln, natural log of x? It's easier to write than log or log base 2, so I just went with natural log. But you could go with log base 2 or log base 17 or whatever you want. You could even, if, depending on how much you remember or know about logarithms, realize that you could write this as the log with a fraction base, a base between 0 and 1, to make it upside down like this particular one is. But I'm going to look at this a little bit differently. So, okay, let's look at the graph of y equals natural log of x. Where is it? There we go. Okay. So here it is. Y equals ln x. So it goes through the 0.10. It has a vertical asymptote at x equals 0. So the graph that we're supposed to be dealing with, it's been shifted. Also, it's upside down. So if you, again, compare, it's upside down. So to make it upside down vertically, that's a reflection. So how about we just throw that minus sign in front? Oh, look, it's upside down. Okay, so we're going to need that minus sign in front. Again, there's other ways to kind of make this happen, but this is what I'm going to do. Okay. So the other thing that happened is it got shifted to the left. There it is. So it looks like it's shifted 1, 2, 3 to the left. So I'm going to have, so far, y equals negative. Let me make this bigger. Okay. Natural log of, okay, shifting it to the left would be x plus 3, right? That would shift it to the left 3. And you can double check that your vertical asymptote's going to be in the right spot by taking whatever's inside your log, in this case x plus 3, and setting it equal to 0 and solving, and we get, oh, x equals negative 3. That's what this is right there. Okay, so far so good. All right, so let's look at our Desmos and see if we do this, if it looks exactly the same. Now, notice we should be going through these two particular points, so we want to double check that. So do parentheses x plus 3, close parentheses. Okay, so we're going through this point at negative 2, 0, but then our other point was 1, negative 2. So 1, negative 2. Okay, that's not quite right. So if I could get it right at 1. Okay, there we go. So we need this point to be down here. So there's some kind of a vertical stretch that's happening. So that means we must have, in addition to that minus sign in front of the natural log, we must also have some other kind of number. So let's see if we can figure out what that is. So I'm just going to call it a, kind of like we've done with leading coefficients before. So we've got y equals negative a, natural log of x plus 3. And so now we're going to use this point, 1, negative 2, to figure out what our a is. And a is going to be kind of weird, but that's all right. Okay, so negative 2 is our y. equals negative a natural log of 1 plus 3. So 1 plus 3 is, of course, 4. So negative 2 is equal to negative a times the natural log of 4. And you can leave off the parentheses once you've got down to just a single term. And then I would probably just drop these negatives off. So it's like you're, what am I trying to say? Multiplying by negative 1 on both sides or something. And so either way, though, you're going to solve for a by dividing. So if we just drop the negatives off, we only need to divide by the natural log of 4 instead of negative natural log of 4. So we're going to get 2 over natural log of 4 for our a. And we want to leave it in exact form. So we're just going to leave it like that. So our final answer, our f of x formula, is, okay, let's see what it was. So going back up here, negative 2 over natural log of 4, and then times, you could do a little times here if you wanted to, but it's not necessary. Maybe I'll just go ahead and put a little times. Natural log of x plus 3. And that ought to be it, but if you want to, make sure, you can put this into Desmo. So we said, 2 over ln 4. And now, when we plug in 1, it is indeed, yeah, if I can get it right, and just there it is, 1 negative 2. So there's only one logarithmic function that looks like this. It's this upside down kind of log that goes through negative 2, 0, and 1, negative 2. There's other ways that you can write this. If you learn about the change of base formula, then you can write this a little bit differently. This would actually be the same, just by the way, the same as having a negative 2, not natural log base 4 of x plus 3. So the change of base formula allows you to it's almost like you're canceling the bases. That's not really what it is, but it kind of seems like that's what it is. Okay, but if you can write it just in terms of whatever your favorite log is, I used ln, but whatever, then that's good enough.